Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on nodal analysis. So now here in the nodal analysis, let us take one example in this figure. So first determine possible number of junctions. So now junction, what do you mean by junction? Junction is a three or more elements connected to one point. Here possible number of junctions, here junction 1 and junction 2. Here possible number of junctions, here junctions here 2. So in that 2, select one junction as a reference junction. Preferably bottom one is the reference junction. So now here assume the junction voltages V1 and V2. Preferably that bottom one is a reference junction. That reference junction voltage is always 0. So now here V2 equals 0. Now third step is if you apply KVL, KCL. So KCL at each node remaining other than this reference junction. Here KCL here. So if you apply KCL at this node, here apply KCL at this node at V1. So now here V1 minus 42 divided by this here. This current, algebraic sum of currents at a node equals to 0. V1 minus 42 by 8, and next V1 minus 0 by 4. Next V1 minus of minus 10. So this is minus plus and this one is a plus 1. So this one V1 minus of minus 10, that means V1 plus 10 by 6. So this is equation number 1. So now here if you simplify this one, so that equals to, so now 0.125 plus 0. This one if you simplify this one, V1 by 8 plus V1 by 8 plus 1 by 4 plus 1 by 6 into V1 plus 10 by 6 is equal to 0. So now here these values are 1 by 8 means 0.125 and 1 by 4 means 0.25 and 1 by 6 means 0.167 into V1. And next thing here minus 42 by this one, minus 42 by 8 means minus 5.25 and 1.67, that value equals to 0. So now here V1 equals to 6.61, and next here this each branch current equals to V1 minus 42 by, this is what is the value of V1, V1 minus 42 by 8 or 42 minus V1 by 42 minus V1 or for V1 minus that resistance. This is the current flowing through the 8 ohms resistor, that equals to 4.42, and current flowing through the 6 ohms resistor V1 plus 10. So this is a V1 plus 10 by 6, that is 2.77, and I4 equals to this one V1 minus 0 by 4, that value equals to 1.65 amperes. In the circuit shown in the figure, determine the all branch current same as in the previous one, but these two branches are extra 6 and 8, and voltage across the 5 ohms resistor, this one. So now here if you apply using nodal analysis only, using mesh analysis we can calculate, but here using nodal analysis. So now here apply KCL at this. So 1 mesh junction 1, this is junction 2, this is junction voltage V1 and V2 is 0, that means V2 voltage is 0, reference junction voltage is 0. Apply KCL at this node, here V1 minus 50 by 3 plus 6. So V1 minus 50 by 3 plus 6, this one. And next V1, this is a V1 minus 0 by 5, this one. And next V1 minus 25 by 2 plus 8, this one. So now this is the mesh junction equation 1. So now here, so now this value equals to V1 by 9, 3 plus 9 plus V1 by this 10 plus V1 by 5 minus 50 by 9 minus 25 by 10, that value equals to 0. Now this V1 equals to 19.9. So after getting the node voltages, you can determine the branch currents. Same thing, I3 current, this I3 current and I6 current is same. So now same current flows to the each one because they are connected in series, and I2 current and I8 current is same. So now this I2 and I8 currents are same. So now here we need this 5 ohms resistor V1 minus 0 by. So this one is V1 by V1 minus 0 by 5. What is the value of V1? So now here this V1 equals to current flowing through this 5 ohms resistor V1 minus this one 3.918. Now apply, this is a determine current flowing through the voltage across 5 ohms resistor is here. This one same thing here. So now here determine first node voltages. Calculate the node voltages. One possible number of junctions here 1, 2 and this one is a 3. So this is 1, this is a 2 and this one is a 3. This voltage is V1, this voltage is V2 and this voltage is V3. Now V1 minus 10 by 1, this one, and V1 minus 3 by 0 by this V3 value 0 reference voltage, V1 minus V3 by 5. Determine junction voltages and branch voltage. And next thing here V1 minus V2 by 2, that value equals to 0. So now if you simplify this one, 1.7 V1 minus 0.5 V2 is equal to 10, that is equation number 1. Next, if you apply KCL at this node, V2 minus V1 by 2 and V2 minus V1 by 2, this one, V2 minus 0 by 10, this one, and this is entering current. So LHS side minus 2 and RHS side plus 2. LHS side minus 2 and RHS side plus 2. This is equation number 2. If you solve this 1 and 2, this is equation number 1 and 2, you will get the V1 and V2. From that V1 and V2, so now here this is V1 minus this voltage across 5 ohms resistor means V1 minus 0, that equals to this 9.09. And currents also you can determine. So now if you substitute V1 and V2, so this is for 1 ohm resistor current, this is for 5 ohms resistor current, this is for 2 ohms resistor current, this is for 10 ohms resistor current, and this is for 2 ohms resistor current. V1 minus V2 by 2 or V2 minus V1 by 2. In the circuit network, so find out the node voltages. So this is here. So junction 1, junction 2 and junction 3, and this one is a junction 4. 1, 2, 3 and 4th, and here assume the junction voltages V1, V2, V3 and V4 equals to 0. So now here V4 equals to 0 means apply KCL at junction 1. So now here V1 minus V3 by 20, V1 minus V3 by 20. Next V1 minus V2 by 5 and V1 minus V4 value is 0 by 10. So first equation is okay. The simplified equation is 7V1 minus 4V2 minus V3 equals to 0. This is equation number 1. This is equation number 1. So now here this is equation number 1. Second mesh equation, V2 minus V1 by 5, V2 minus V3 by 10. V2 minus V1 by 5, V2 minus V3 by 10. And here this is entering current, LHS side minus and RHS side plus. So minus 10 here. So now here the simplified equation, minus 2V1 plus 3V1 minus V3 equals to 100. So this is second equation over. This is equation number 2. And after the third mesh equation, V3 minus V2 by 10. And next V3 minus V1 by 20, this one. And V3 minus 0, V4 by 5. V4 is 0 and 5. So this is, so the simplified equation is minus V1. This is equation number 3. Minus V1, minus 2V2 and plus 7V3. So now this is equation number 1, 2 and 3. If you solve this 3 equation, you will get V1, V2 and V3. These are the node voltages. Next, find current flowing through the 20 ohms resistor using nodal analysis. Using nodal analysis. So first here junction 1, junction 2, this is a junction 3. Here junction voltage V1 voltage, this one is a V2 voltage and this one is a V3 voltage. V3 voltage is 0 because it is a reference junction. Select one junction as a reference junction. If you apply KCL at this node, V1 minus 20 by 5, this one, and V1 minus 0 by 10, V1 minus 0 by 10 and V1 minus V2 by 10, that is equation number 1. That simplified equation is here. So now if you simplify this one, this is the minus V1 minus 4V1 minus 40 minus V2 equals to 0. This is the equation number 1. Now here if you apply KCL at this node, V2 minus V1 by 10, V2 minus V3, that means 0 by 20, this one, and it is entering current means LHS side is minus and RHS side is plus. And the simplified equation 3V2 minus 2V1 equals to 80, that is equation number 2. Solve these two equations, you will get the V1 and V2. V1 equals to 20 volts and V2 equals to 40 volts. So calculate this 20 ohms resistor current equals to V2 by V2 minus 0 by. So now what if V2 equals to 40 means I2 equals to V2 minus 0 by 20, that equals to 40 by 20, that means 2 amperes. And next thing here, calculate the node voltages. First here possible number of this V1 and V2 are the node voltages. So possible number of junctions here 1 and 2 and this one is a 3. So junction 1, junction 2 and junction 3. So junction, if you junction 1 voltage is V1, junction 2 voltage is V2 and junction 3 voltage is V3. V3 equals to 0. V3 as a reference junction. V3 as a reference junction. Now if you apply KCL at this node, V1 minus V2 by 4, V1 minus V2 by 4 and next V1 minus V3, that value is 0 by 2 and this current is entering. LHS side minus plus V1 minus 2 and minus 5 equals to 0. Entering current LHS side minus 5 and RHS side plus 5. This is equation number 1. So that simplified equation 3V1 minus V2 is equals to 20. So now second mesh equation here, apply KL V2 minus V1 by 4 and next V2 minus 0 by 6. So now I will write V2 minus V1 by 4 plus V2 minus 0 by 6 plus this current is entering, so is equal to, so minus 4 and this one is a plus 5, leaving current equals to 0. So now this equation is same. So if it is RHS side here V1 minus V2 and V2 by 4 and this is plus 5 and this one is minus. So this is 10, I think. So this is 10 is entering. So 10. And next the simplified equation minus 3V1 plus 5I2 equals to 60. And if you solve this one 1 and 2, you will get the V1 and V2 value. This is a V1 and this one is a V2. So these are the node voltages. Calculate the node voltages here. So junction node 1, node 2 and this one is a node 3. Node 1, node 2 and node 3. So now possible number of junctions here. So 1, 2, This one is a 3, V1, V2 and V3. Select one junction as a reference junction. That reference junction voltage is 0. Apply KCL at this node, at node 1. So that means this one, V1 minus 0 by V3 by 10 plus V1 minus V2 by 2, V1 minus V2 by 2, and this is leaving current, so that is plus 6, LHS side and RHS side minus 6, and V1 minus 0 by 5, that equals 0. Algebraic sum of currents at a node equals to 0. So now here minus V1. So now if it is this RHSL minus V1 by 10 and minus V1 by 5, and next here 6 is this same, and V1 minus V2. So now the simplified equation 60 minus 8 V2 plus 5 I2 equals to, that is equation number 1. Now second mesh equation, apply KCL at this node. So V2 minus V1 by 2. So now here V2 minus V1 by 2 and V2 minus V1 by 4, V3 by 4, V2 minus 0 by 4. It is entering current, that is LHS side. Let me change the color over here. This is, so now this is minus 3 amperes, it is entering current, and 6 is entering plus minus 6. So these 3 are entering, minus 6 and minus 3 are entering, LHS side minus. So algebraic sum of currents at a node equals to 0. So now if you simplify this one, 36 equals to minus 2V1 plus 3V2 equals to 36. That is equation number 1 and equation number 2. By solving this 1 and 2, you will get the values. V1 equals to 0 and V2 equals to 12 volts. Solve the V1. So solve this V1 using nodal analysis in the given circuit. So now here possible number of junctions here. This is one junction 1 and this is one junction 2. Determine possible number of junctions is here 2, and this is step 1. Step 2 is here. So assign junction voltages V1, V2, so V1 and V2. In that select one junction as reference junction. So here preferable voltage is bottom junction is the reference junction, V2 equals to 0. That means that is reference junction, ground junction, V2 equals to 0. Now third step is apply KCL at node 1, not required here. So now if you apply KCL at this node, now I am writing here, this is potential is V1 and this potential is 10. So now potential difference between these two is V1 minus 10. So now these currents, how many currents here, how many elements connected to this node? 1, 2 and 3 and 4. So now here V1 minus 10 by 5, this one. So now V1 minus 10 by 5. So this algebraic sum of currents at a node equals to 0. So now this current equals to V1 minus 10 by 5 and V1 minus 10 by 5. So this one, first one, this one V1 minus 5 by 10, V1 minus 10 by 5 and V1 minus 10 by 10, this one, and V1 minus 0 by 10, this one, and next V1 minus 20 by 4. So now here how many? So now this is equation number 1. Here we have only 1. So now if you simplify this one, so V1 is a common. So 1 by 5 plus 1 by 10 plus 1 by 10 plus 1 by 4 into V1 and minus 10 by 5 minus 10 by 10 minus 0 and minus 20 by 4 equals 0. So now this equation is here 0.2 and 0.1, 0.1 and 0.25 into V1. This is 2, 1 and 5. So now if you simplify this one, V1 equals to 8 by 0.65, that equals to 160 by 13, that equals to 12.308. I hope all these problems are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.